Hi, guys.
Hi.
I knew you were going to do that. So today we're going to do describing distributions with numbers. So this is your third page in that notes packet. Yesterday we did histograms, so we're going to kind of talk about numbers now. We talked about the center. Now we're going to talk about what numbers we use when we use them. I should say that. What numbers we use for which graphs. So the mean is by far the most common measure of center. Okay. The mean is sensitive to the influence of a few observations. So, you guys, that means that it's pulled in one direction or other. So, when we talked about right skewed and left skewed, the mean is pulled in the direction of its tails. So, a skewed distribution with no outliers will also pull the mean toward its long tail. So even if it doesn't have outliers, it's just what I just said. You guys, the outliers is really going to affect the mean, and those tails, if it's skewed, the mean is always pulled in the direction of the tail. So if it's left skewed, it's pulled to the left. If it's right skewed, it's pulled to the right, okay? So remember, right skewed, left skewed is where the tail is not where the most of the data is. Okay, so our big thing that you need to know is that the mean is not a resistant measure. What that means is it's pulled, so it's being influenced. A resistance measure isn't influenced by anything. It will stay constant. Where the mean is it's not resistant. It's really influenced by high values, low values, and pulled up by the tails. So that's what you need to know. Okay, the median is the formal version of the midpoint. The median is symbolized with a capital M. Okay. The one thing about medians that I really like is that medians require little arithmetic. They are easy to find by hand. For small sets of data. So like you guys, like our dot plots and our stem plots, those are perfect to find the median because stem plots and dot plots are used for small sets of data. Whereas histograms and box plots are going to be used for those larger sets of data. I will tell you that the data that we have, that we're using and that we're, I don't want to say manipulating, but that we're using for our stem plots, what we collected, that is kind of considered a small set of data. And we'll talk about whether it's population or sample. Okay, so now you have the mean and the median. And the one thing that you need to know about the median, and I don't know why I don't write here, is the median, so we're just going to kind of write to the side. We're going to write the median is resistant. Whereas the mean is not. The median is resistant. So the median will stay Like for outliers and everything, that's the nice thing is that the median will stay constant. So the median, that midpoint in the median is resistance where the mean is non-resistant. And the AP graders, love that type of stuff. Okay, so they will ask you. So you have two measures of center right now. You have the median and you have the mean. The mean is not resistant, the median is. Now from there, we're gonna actually talk about I'm about to tell you. It's called the 5-number summary. So you have the minimum, okay, that's your smallest value. You have Q1, and I'm gonna write what Q1 means. You have your median, remember M is for median, and then you have your quartile 3 and your maximum. So Q1 means quartile 1, and Q3 means quartile 3. You guys, if you ever hear someone say, what is quartile 2? That's your median, okay? We never refer to it as quartile 2, but you might hear that it's quartile 2. The other thing you need to know is that this breaks up your data into groups of 25. So between the minimum, oh my gosh, between the minimum and quartile 1, 25% of your data lies. Between quartile 1 and the median, another 25%. Between the median and quartile 3, 25%. And between quartile 3 and the maximum, there's 25%. Okay. So, why would we use the 5-number summary? So it improves our description by looking at the spread of the middle half of the data. So what that means is it really improves our discussion between the 50%. So we really look at all the data that's between quartile 1 and quartile 3. That data is really important. Whereas most times we're looking at the spread of everything. When we're talking about the 5-number summary, it really allows us to talk about everything, but it also shows us where the middle 50% of the data lies. And remember, the middle 50% lies between quartile 1 and quartile 3. Okay. Simple measure of spread. That gives the range over covered by the middle half of the data is called the interquartile range. And we abbreviate it IQR. So the IQR is quartile 3 minus quartile 1. So that's a simple measure. Again, it's covering that 50% of the data. It's going to tell you how big a spread do you have. So how big of spread is it between quartile 1 and quartile 3? That's the big thing. So there's one more thing that I want to do on this page with you before we talk about some problems and you guys get up and you get the book. Okay. So you use the IQR to find your outliers. So your outliers, it's actually called the 1.5 rule because you take 1.5 and you multiply it by the IQR. Okay, so the outliers equals 1.5 times IQR. So what you do is you multiply 1.5 times IQR and you take that and you're going to subtract it from quartile 1. And anything below this number, so whatever your quartile 1 is minus this, anything below this number is considered an outlier. That's why it's called the 1.5 rule. So anything below that is called an outlier. Now, if you do it for the bottom half of your data, you have to do it for the upper half. So this time you're going to take quartile 3, and instead of subtracting, we're going to add that 1.5 times IQR. And anything above this number is considered an outlier. So below this number is an outlier, above this number is an outlier. So we've talked about mean being the most common measure of center. It's not resistant. We've talked about the mean. It's an easy way for small sets of data to find the median, to find the middle set of your data. And it's resistant. That means that you can have outliers and the median is going to stay consistent. That's a better word than constant. It's going to be consistent. The median will stay consistent where the mean is going to be pulled. And then we were talking about the 5-number summary. The big thing about the 5-number summary is that we can look at the middle 50% of the data, which lies between quartile 1 and quartile 3. And we can talk about spread using the IQR, and we can find outliers. Good for now? Bye, Hybrid Bee.